Accept and ExceptBy methods in LINQ. To grasp these concepts, let's start with a simple analogy from the world of mathematics. Imagine you have two sets of numbers. Set A contains the numbers 1 through 8, and set B contains the numbers 6 through 13. In mathematics, when we talk about the difference between two sets, we are interested in finding elements that are in the first set but not in the second. So, the difference between set A and set B would give us the numbers 1 through 5, as these are in set A but not in set B. This concept mirrors what the Except method does in LINQ. It helps us find elements that are present in one collection but absent in another, much like subtracting one list of numbers from another in our math example. But what if our sets were a little more complex, containing objects with multiple properties, and we wanted to compare them based on just one attribute? That's where ExceptBy comes into play. It allows us to specify a key to compare by, akin to filtering one set of complex numbers based on a specific characteristic, such as only looking at the even numbers in each set before performing our subtraction. Let's dive deeper into these methods, understand their syntax, and see them in action with real code examples. As mentioned, the Except method is used to find elements that are present in the first collection but not in the second. It's like subtracting the second list from the first one. This method is ideal for simple data types, such as integers and strings. It comes with two overloads. The first one is the following, which compares elements directly. So, no need to add any expressions or parameters. We only use both sequences we want to compare. The result will be a new sequence that contains only the elements that are available in the first sequence, but not in the second. Imagine you have the following two arrays of integers. By using this query, we will get the following sequence, where we have the elements unique to the first array. This sequence is of type 𝗖𝗵𝗽𝗀𝗀𝗀𝗀. To convert it again to array of integers, we can apply the toArray method. This is how does the first overload work in general. The second overload includes a comparer, allowing for custom comparisons. It's like the second overload of distinct method we discussed in our previous video. This feature is especially useful for nuanced comparisons, such as ignoring case sensitivity between two lists of strings. By employing a custom comparer with Except, we can tailor our comparison logic to meet specific needs. Let's explore an example of using this overload with data tables. Suppose we have these two tables, which have the same columns, but the content is different. Our goal is to find the rows, which are available in the first table, but not available in the second table. As you know, DataTable is a complex data type, therefore we cannot compare tables without using a comparer. So, we will use the data row comparer as following. The result of this query will be the following table. As you can see, we got only these rows, because they are only in the first table, but not in the second one. This is also how to use the second overload of Except method. Let's move on to the second method, ExceptBy, which is a bit more specialized. It allows you to specify a key to compare by, making it incredibly useful when working with complex data types, or when you want to compare based on specific properties of objects. It comes with two overloads. The first overload allows you to define a key selector function. So, here we set a lambda expression to define which property should be used to compare the sequences. The expression refers to the first sequence, not to the second one. To understand it better, let's consider the following example. Suppose we have a list of strings that contains different words. Our goal is to get all words from this list, except the words that have a length of 3 or 5. So, I will create a list of integers that contains the numbers 3 and 5. This will be the second sequence. Now the query will be as following. We first have the list of strings we want to filter. Then we have the list of integers that contains the lengths we don't need to get in the result. And the last thing we have is the lambda expression. Here we use the length of the words. This means, this expression refers to the first list that contains the words. So, the parameter w represents the words inside the first list. And this expression returns an integer number. It's the same type as what we have in the second sequence. This query returns the following sequence that contains all words that don't have a length of 3 or 5. This sequence is of type 𝗖𝗵𝗽𝗀𝗀𝗀𝗀, which can be converted to list of string using toList method. So keep in mind the expression refers to the first sequence, and the return type of the expression must be of the same type of the second sequence. And both sequences must not be of the same type, such as this example, where we have a list of strings and a list of integers. This is also the difference between except and ExceptBy methods. Except method takes two sequences of the same type, while ExceptBy takes two different types. This was a simple example of using the first overload. Let's explore another practical application of the ExceptBy method. Imagine we have an entire list of dates for the month of August 2024, and we want to filter out specific dates. How do we do this efficiently? Let's implement this use case in UiPath. We start by using activities in UiPath to generate all the days of August 2024. Here we define the month and the year. Instead of manually defining the number of days, we use an activity to calculate the count dynamically, ensuring our solution is adaptable for any month. For August, it will naturally return 31 days. Next, we employ a LINQ query, using the range and select methods we have learned about before, to generate an array of DateTime objects representing each day of August. This means, this LINQ query returns an array of DateTime that contains the 31 days of August 2024. Now comes the part where we want to apply the ExceptBy method. Suppose we have an array of integers representing specific days in August we wish to exclude, let's say the weekends. Here's how we set up our LINQ query in the assign activity. We have all days, an array of DateTime objects for the month, and exclude days, an array of integers for the days we want to exclude. The key part is the lambda expression, which tells ExceptBy to compare the day of the month from each DateTime object in all days against the integers in exclude days. So, here we are using the property day, which refers to the first sequence. And the return type is an integer number, which is the same type as what we have inside the second sequence. Lastly, we use a writeLine activity to output the filtered dates. Each element in the array will be written in a new line in the console. Let's run the code to check the output. The result is an array of DateTime objects for all the days in August 2024, excluding those specified in exclude days. And that's how you can use the first overload of ExceptBy method to filter dates effectively in UiPath. In our next step, we are going to dive into a more advanced feature, the second overload of the ExceptBy method. It has the following structure. This particular overload enhances our comparison capabilities with the addition of a comparer. A comparer lets us define how the elements of two sequences should be matched against each other, which can be especially handy for complex comparisons. To understand this overload better, let's consider the following example in UiPath. We have two data tables, Table 1 and Table 2. Each consists of two columns, Product ID and Product Name. Our goal is to sift through Table 1 and pick out the rows, whose product IDs are not present in Table 2. But there's a catch, we want to disregard the case sensitivity of the product IDs, treating a BCD the same as a BCD. Here's the query using the second overload of ExceptBy method. The first sequence is the enumerable collection of rows from Table 1. The second sequence is the collection of product IDs from Table 2, which we convert to strings for comparison purposes. So, this sequence is of type IEnumerable of string. The core of our LINQ query is the lambda expression. This is where we determine the basis of our comparison. For Table _1, we select the product ID and convert it to a string, aligning it with the type in our second sequence. To handle the case sensitivity, we introduce a string comparer, string_comparer.ordinalIgnore_case. This tells the query to treat product ID strings with different cases as equal. After constructing our query, we use the copy to DataTable method. This transforms our filtered sequence back into a data table, ready for further processing. Finally, to display our results, we loop through the resulting data table with a for each row activity, where a writeLine activity will print each row's content. Let's execute the code to check the result. As you can see, we got only the rows from Table 1, that have product IDs not found in Table 2, all while ignoring differences in letter casing. And that's the power of the second overload of ExceptBy. It provides us with precise control over how we want to compare our data, making it an invaluable tool for comparisons. Before ending this video, let's summarize both methods. The except method in LINQ is a set operation, that produces the difference between two sequences by comparing the whole objects. It has the following two overloads. It returns a new sequence containing all the elements from the first sequence that do not appear in the second sequence. The method requires that both input sequences are of the same type, since it compares the objects in their entirety. This method is typically used when you need to find elements that are unique to one list in comparison to another. The ExceptBy method, on the other hand, is a specialized LINQ method designed for comparing two sequences based on a specific key selector function. It has the following two overloads. It returns a new sequence consisting of elements from the first sequence, for which the key selector returns a value that is not found in the second sequence. ExceptBy differs from Except, in that it allows comparing two potentially different types of sequences by specifying which property of the object should be compared. This method is particularly useful when the comparison should be made on a single aspect or property of complex objects, rather than on the entire object. In summary, use Except for a full comparison where the details of each item matter, and reach for ExceptBy when you need to focus on specific attributes or need more nuanced control over the comparison logic. And there you have it, a comprehensive guide on when and how to use Except and ExceptBy in your LINQ queries. By choosing the right tool for the task, you can handle data comparisons with finesse, whether you are dealing with simple lists or intricate data structures.